So let's talk about self-destruct. So self-destruct is an EVM opcode, and it's been present since Ethereum's Genesis launch. The self-destruct opcode, when it is encountered, immediately transfers the balance of an executing contract, the entire balance of an executing contract, to a beneficiary and returns execution to the calling frame. The beneficiary being any account you choose, and it's an argument of the self-destruct opcode. After a transaction finishes successfully where self-destruct has been called, any contracts which self-destructed are removed from the state. Self-destruct was modified in the London hard fork. So basically self-destruct has existed from the start as a way for contract user, or as a way to voluntarily free up the state by removing contracts that are no longer used. And one of the things it did was basically, so if you were to self-destruct a contract, it would add gas per storage slot freed to the gas counter. So basically, basically the problem that this created is that created an incentive for people to create contracts, fill them up with junk storage when the gas prices were low, and then later on in times of high demand, they could then self-destruct these contracts and get some of the gas back that they had previously stored. So this was removed in the London hard fork. Just as a random aside, the parody multisig hack of 2017 was, I guess I shouldn't say caused by self-destruct, but a library component of the parody multisig contract was self-destructed. And so, historical tidbit. So yeah, why remove self-destruct? So it's a constant cost operation. I think it costs 8 gas. But the problem is it can cause you to change an arbitrary amount of state depending on how much code and, well, how much storage really the contract you're self-destructing uses. So from a client perspective, this makes creating a port-performant implementation that can handle this case a bit more complex because you're potentially removing a lot of keys in your database. So another issue is that if we go stateless and we start having, so when we go stateless in a Verkle, say in a situation where Verkle gets adopted, when you're doing self-destructs, you're really bloating the witness size potentially. So that's a problem. And then the third one is just kind of, self-destruct is complex for implementing. It creates weird logic in clients, and really there's not as much on-chain usage as that complexity warrants, so we should remove it. So EIP 4758 is a proposal to do this, and EIP 4758 renames the self-destruct It renames the self-destruct opcode to send all. So it keeps the behavior where you immediately transfer the balance of the invoking contract to a target beneficiary and returns execution to the calling frame. But the only difference is that contracts which invoked send all are not removed from the state after the transaction finishes successfully. So there are some backwards compatibility concerns, and I've brought up a few here. So right now you can redeploy contracts at the same address using a combination of create2 and self-destruct. And after this change, contract deployments in this manner, redeployments in this manner will no longer work. they'll no longer work because the original contract remains on the chain, so you can't redeploy it. So ephemeral contracts are something else that will probably be broken. And so these are contracts which are created and destroyed within the same transaction, and their code never actually lives on chain. But there may be issues because any contract that is intended to be executed ephemerally after this will leave its code on chain. And then kind of a third one that may not really cause any backwards compatibility concerns, but is kind of something to note and maybe consider, is that currently if you self-destruct, so if a contract executes self-destruct and the beneficiary is itself, that ether is removed from circulation completely. And after this change in 4758, if it goes live, that will no longer, it will just remain in the account. Yeah, so I did some analysis to look at the usage of contract redeployments and ephemeral contracts on chain, specifically focusing on the time period since the London hard fork. And so I was trying to identify creators of ephemeral and redeployed contracts, and also the created, and also the accounts where they were created, and then look at the ether holdings of these accounts. So actually, there weren't. Well, first of all, there wasn't a huge usage of contract redeployments or ephemeral contracts. I mean, you can look at the numbers in the repo I linked, but even among these, there were only several of them that actually had significant ether balances. So two of these contracts were from Pine Finance, which is a DeFi application. Their source is verified on Etherscan. Those definitely warrant further analysis if 4758 is to go live. And then there's another outlier, a whale account that is just tagged as an MEV bot and doesn't have verified source. So yeah, so next steps for self-destruct removal, I think getting accepted into a subsequent hard fork. There needs to be closer analysis of contracts that could potentially be affected. And in addition, I think that there could be potentially additional analysis work to identify more of these contracts. For example, looking for contracts that maybe have large ERC20 or other token holdings to see if any were missed from the analysis that I've done. There are some spec tests. I've linked them here. Certainly, if this is to go forward, additional spec tests will be needed. And as well as additional client implementations. Right now, there is a draft PR to implement this in Geth, and that's it. Yeah, so that's all I have right now. Thank you for listening.